All right, now what we're going to do is use what we've learned about limits to apply them directly to something that's the very beginning of calculus. In calculus, one of the biggest thing that comes up in the whole first semester of calculus is slope of a tangent line. You've been used to finding the slope before of a line. Well, what if you want to find the slope of a curve? Like here, if I have a curve that looks like this, how do you find the slope, like right here? Well, you can't pick 2 points because it's changing all the time. So the slope at that point is defined as the slope of a tangent line. If you remember geometry, remember a tangent line to a circle is a line that touched the edge of the circle just in one point like that. That's what we're talking about, a tangent line. It's a line that touches this curve in just one point right there. Well, if we can find the slope of that point, that is the slope of the tangent line at that point. So that's our slope. Again, this comes up all the time in calculus. Now, to find the slope of that point, this will be defined more for you when you take calculus, but we have a formula at the very beginning of calculus. You have a formula for the slope of a tangent line. And the formula looks like this. It has the limit as h approaches 0. So it starts with that. The limit as h approaches 0. And then there's 3 things. It starts with f of x plus h. This is the part that gives students the trouble the most. For some reason, we can't get a handle on what this means. Remember, in function notation, whatever's in parentheses is what you put in place of x. So we're going to take our function whenever we see an x, we're going to plug an x plus h in its place. Then the second thing is minus f of x. Well, that's just the original function. We already have that. And then you divide all of that by h. So you do that, you do the limit as h approaches 0, and that's it. So if I had this one right here and I said, find the slope of a tangent line at the point -3, 1. Okay, first, so we're going to use this formula. So the slope of a tangent line equals the limit as h approaches 0. Now the first thing is f of x plus h. Remember, that says we're going to put x plus h in for x. So for this x right here, we're going to put an x plus h in place of that x. So that means we're going to have 5 times x plus h squared minus 2. So that's this first part. 5, in place of that x, we're putting an x plus h. So it is squared, and then we still have a minus 2. So that's the first part. Now it's minus f of x. Well, f of x is just our original function. 5x squared minus 2 all over h. And that's how we start. Wherever you see an x, we're going to put an x plus h in its place. Now we have to do some simplifying. Again, as I mentioned in one of the others, you need to keep your limit notation on there until you actually find the limit. All right, we need to FOIL this out. Well, that's going to be x squared. If you took x plus h times x plus h, so first times first is x squared. The outside 2 is an hx. The inside 2 is an hx. So that's 2hx. And then last times last is h squared. Now we still have a minus 2. Don't forget about that. And here we're subtracting all this. So that'll be minus each one of those. So minus 5x squared and minus a negative 2. So that's all we did there was multiply out the x plus h squared. Now we have a 5 outside those parentheses. Let's distribute that 5. So that'll be 5x squared plus 10hx plus 5h squared. Now we have a minus 2, a minus 5x squared, and a plus 2. So we got that top all worked out. Now at this point, there should be a lot of stuff that cancels out. Notice on top we have a 5x squared and a negative 5x squared. Those cancel each other out. We have a positive 2 and a negative 2. Those cancel each other out. So all we have left is this part right here. Let's write that out so we can see it. So it's 10hx plus 5h squared all over h. Well, now, we still can't find the limit because if I put 0 in for h, I have a 0 on the bottom. But on the top, we can factor that. They both have an h in them. Let's factor an h out of there. So that'll be 10x plus 5h all over h. Well, now we have a common factor on the top and bottom. We can divide top and bottom by h. We're just left with that. Well, we got rid of our denominator, so now we can do direct substitution. If I put 0 in for h, I get just plain 10x. So that's our slope. We had to do all that to find our slope. Now, notice this equation says, there's our slope. If they just said find the slope equation, that's it. Our slope is 10x. Now notice it says find the slope at the point negative 3, 1. Well, that means x is negative 3. Let's put negative 3 in here for x. Our slope at that point is negative 30. So that would answer the whole question. So this would be our slope equation. Slope equals 10x. And when we plug in negative 3, we get negative 30. That's the slope of a tangent line. Now there's a lot of terms for that in calculus. This, what we did here, that slope of a tangent line is also called the derivative. This process that we just did, all of those steps, is called the definition of derivatives. It's one of the first things you do in calculus. It takes a while, it's kind of long. Later on, they'll show you a shortcut. But that's called the derivative. That's the slope of a tangent line. Now the symbols for a derivative, the three most common ones is, see how there's a little apostrophe here? That's called f prime of x. So that's called f prime. That's a derivative. Or you can just put it on the y. That's called y prime. That's a derivative. Or you have dy over dx. You just say dy dx. That's another notation for derivative. All of those means derivative. If you're doing a problem, a big thing they do in calculus is find an instantaneous rate of change. This has a lot of applications in real life. Flow rates, stress tests, change in velocity, lots of things, instantaneous rate of change. So if I gave you this question, the word like this one, find the derivative. Well, what we did right here, that's the definition of derivative. We would go through the same process here. So if I say find the derivative of f, well, let's call that f prime. Remember, the derivative is something prime. So we're going to have the limit as h approaches 0. Now again, our three things. Remember, for f of x plus h, we're going to plug an x plus h in here and in here. So in both x's, we're going to plug in x plus h. So it's going to be 2 minus 3 times x plus h plus x plus h squared. So that's f of x plus h is all that right there. Now it's minus f of x. Again, f of x is our original equation, so 2 minus 3x plus x squared. And that's all over h. Now let's do some simplifying. Here I have a 2. Here I need to distribute the negative 3, so negative 3x minus 3h. Here we need to multiply out x plus h. Well, we did that before and got x squared plus 2hx plus h squared. Here we're subtracting all of this, so that'd be minus 2 minus a negative 3x minus x squared. Got a lot of stuff there. Now let's see what cancels out. Well, let's see. I have a positive 2 and a negative 2. I have a negative 3x and a positive 3x. I have an x squared and a negative x squared. So what do we have left? Well, I see a negative 3h. I see a 2hx and an h squared. Let's just write so we can see that. We still have our limit notation. So we had a negative 3h plus 2hx plus h squared all over h. Now we still have an h on the bottom, so we have to get rid of that. Well, on the top, those all have an h in common. Let's factor that h out of there. So that'll be the limit as h approaches 0. If I factor an h out, that'll be a negative 3 plus 2x plus h all over h. Well, now we can divide top and bottom by h. We're left with the limit as h approaches 0 of just that top, -3 plus 2x plus h. Well, now let's plug 0 in for h right here. Well, that leaves us with -3 plus 2x. That's our derivative. The same exact thing we did on the problem before. It's just called a derivative. Now notice it says find the derivative of x equals -1. So let's put -1 in here for x. That'll be -3 minus 2 is -5. That's f prime of -1. Now a lot of times when you do this, they will ask you to find the equation of a tangent line. Now, to do that, we're going to go back. I don't know if you remember, we stressed before that the point-slope form is used a lot in calculus. Well, this is exactly where it's used. I can guarantee you when they take the AP Calc test this spring, there will be a question on there where it says, find the equation of a tangent line at a point. And they're going to do just what we're going to do. They're going to find the derivative, find the slope, and plug that into point-slope form. So like here, it says, find the equation of a tangent line at -3,1. Well, that's what we did up here. -3,1. So here we found out our slope was -30. Our point we know is -3,1. Let's plug that into our point slope form. So this is x1 and y1, and this is our slope. So the formula says take y minus y1, so y minus 1 equals the slope, -30, times x minus x1, so x minus a -3. So if we distribute here, that's -30x. That's going to be plus 3, so minus 90. If I add 1, there's our equation of a tangent line. So once you have the slope, by using the definition of derivative or from the finding the slope of a tangent line, you just plug that in the point they gave you into the point slope form, and there's your equation of a tangent line. Okay?